Alright, thanks for watching, and today I would like to discuss 6 limits with L'Hopital's rule that everyone should know. So that's very useful to know, starting with the following one, which I call persevere. And you'll see why. So let's calculate the limit as x goes to 0 of 2 sine of x minus sine of 2x over x minus sine of x. Now, remember, always before doing L'Hopital's rule, you have to check that this limit is of the form 0 over 0. So this is 0, right? Sine of 0 is 0, sine of 0 is 0. So this is 0, and then 0 minus 0 is 0. So indeed, this is L'Hopitalizable. And then what does L'Hopital's rule say? It simply says to take the limit of this ratio, just take the limit of the derivatives. So what this becomes is limit x goes to 0 of the derivative of that, which is 2 cosine of x, minus Chen Lu 2 cosine of 2x. So cosine of 2x times 2, and then 1 minus cosine of x, which still doesn't really give us an idea of what's going on. So it's a little bit more simplified because there's no more x. But let's see if we can do better than that. And again, we want to use L'Hopital's rule again. So let's check if it's of the forms like 0 over 0 or infinity over infinity. Well, here, 1 minus 1 becomes 0. And then 2 minus 2 also becomes 0. So it's ready to be L'Hopital. And so what we get is we do the derivative again. So minus 2 sine of x. And then minus 2 minus sine of 2x times 2. You just take the derivative of this. And then minus minus, so plus sine of x. Okay, and then, so what we have, we then just get the limit as x goes to 0 of, so minus sine of x, minus 2 sine of x, plus 4 sine of 2x, divided by sine of x. And then there are many ways of figuring this out. Either split it up, that would be one possibility, or why not, since we're already so much deep into trouble, let's apply L'Hopital's rule again. Because notice, this is of the form 0 over 0. So that's of the form 0 over 0, and therefore we can use L'Hopital's rule again. Then that's the limit as x goes to 0 of minus 2 cosine of x, and then plus 4 times 2, so 8 cosine of 2x, over cosine of x. And now let's see what happens when we plug it in. It becomes minus 2 cosine of 0, so minus 2 plus 8 cosine of 0, so 8 over 1, and in the end, we get a limit of 6. I mean, who would have known? How nice is that, huh? And then, let me just check if that's correct. Yes, okay. So we have that. So that's the one limit I think everyone should know because it teaches you to persevere with L'Hopital's rule. Of course, if something gets too complicated, might not always be the good idea to use L'Hopital's rule. But that's not what the video is about. It's an advertisement for it. Next one is something you may or may not have seen. So the point is, L'Hopital's rule applies for 0 over 0 or infinity over infinity, but you can also adapt familiar situations to make it of the form 0 over 0 or infinity over infinity. For instance, this limit x goes to 0 plus x times ln of x, which, if you want, is of the form 0 times minus infinity. Well, in order to turn this into 0 over 0 or infinity over infinity, we need to transform this into a fraction. And here's how you do it. Instead of having x, write this as 1 over 1 over x. 1 over 1 over x. The reason being, that way you transform it into a fraction. And then we get ln of x. And so we get limit x goes to 0 plus of ln of x over 1 over x. And notice now, this is of the form infinity over infinity. So strictly speaking, minus infinity over infinity, which is okay. And then now we can apply L'Hopital's rule, and this gives you the limit as x goes to 0 plus of 1 over x over minus 1 over x squared. And that gives you the following. That becomes the limit as x goes to 0 plus of 1 over x times minus x squared, which simplifies to the limit as x goes to 0 plus of minus x, and that's 0. So, in other words, in this tug of war between 0 and ln of x, it turns out x wins, because x kind of goes faster to 0 than ln of x does, to minus infinity. And again, the point is, those, even 0 times minus infinity or something, you can turn this into a situation where you apply L'Hopital's rule. And by the way, so as a general rule of thumb, I would say ln is always best to put it on the numerator, but e to the x or something is best to put it on the denominator. Like if you had to do x e to the x as x goes to minus infinity, you would write it as x of 1 over e to the x, which becomes x over e to the minus x. So that's one thing. Now moving on, here's another very nice L'Hopital problem. Again, which is a situation where you don't really think about it, but it is true. So limit, it's not the one I was thinking of, but this one is also very nice. Limit x goes to infinity of x minus ln of x. Just to show you, don't forget about all the other rules you've learned. So this is of the form infinity minus infinity. And usually the way you deal with those kind of expressions is you factor out x from this expression, basically to turn this into a, not into a Chen-Lu, into a L'Hopital problem. 1 minus ln of x over x. And as a parenthesis, let's see what happens to this expression. So limit x goes to infinity of ln of x over x. Well, notice, this is of the form infinity over infinity. So you can just use L'Hopital's rule, and you get limit x goes to infinity of 1 over x over 1, and that's limit x goes to infinity of 1 over x, and that's 0. So the point is, this expression goes to 0, so here we just have something of the form infinity times 1 minus 0, and that's just infinity. infinity times 1 is infinity. If I give you one check with infinitely many dollars, you would say, I'm a pretty rich person. So we're halfway done with this. Now, let's move on to the problem I was very excited about, which is the following, because it's quite tricky, I would say. Limit x goes to 1 of 1 over ln of x minus 1 over x minus 1. Again, it's like of the form, I guess, 1 over 0 minus 1 over 0, so possibly infinity or something, but so possibly infinity over minus infinity, but depending on the sign. But the point is you have this difference of ratios, so let's just put it on a common denominator. So limit x goes to 1 of, let's see, x minus 1 minus ln of x over ln of x times x minus 1. And notice this is of the form 0 minus 0, which is 0, over 0 times 0, which is 0. So this is of the form 0 over 0, which means you can apply L'Hopital's rule. Now, I gotta find a mnemonic for L'Hopital's rule, like Chen Lu, right? The L'Hopital Lu, or I don't know. Anyway, and then we get the derivative of the numerator, which is 1 minus 1 over x. And then for the denominator, you use the product rule, or what's called the product rule. So you first differentiate this, 1 over x times x minus 1, plus ln of x times 1. And then notice what's nice is you can write this, also on a common denominator. And what you get is the limit as x goes to 1 of, let's see, x minus 1 over x divided by x minus 1 plus x ln of x over x. So this cancels out, and you're left with the limit as x goes to 1 of x minus 1 over x minus 1 plus ln of x, which is still of the form 0 over 0, which means you have to apply L'Hopital's rule again. So this becomes the limit as x goes to 1 of the derivative of the numerator plus 1 plus derivative of the denominator, and then that one you can just plug in 1 plus 1 plus 1, 1 over 1 plus 1, and that's 1/2. Who would have thought that sort of the difference of this goes to 1/2? I don't even believe it. Let's see. Yeah, that's what it is. Interesting. Okay. Okay, that's one. And then the last two examples deal with powers of functions. So, in other words, what do you do if you have something like 0 to the 0, or infinity to the 0, or 1 to the infinity? Starting with the following very classical example. This one is not good. How about limit x goes to 0 plus of x to the x? So notice this is of the form 0 to the 0, which is an indeterminate form. The reason being, this 0 wants to pull a number towards 0, but this 0 wants to pull numbers towards 1. Like 2 to the 0th power is 1. So you have this tug of war going on between the base and the exponent. Okay, how do you deal with it? Well, the way to transform this thing into a product is by using ln. So let y be x to the x. Then ln of y is ln of x to the x, which is x ln of x. Then let's figure out what happens at let's figure out what happens to ln of y as x goes to 0 plus. So that's limit x goes to 0 plus of x ln of x, which I believe I've already done. So if you look at the previous example, this just becomes 0. Again, and the way you do this, in case you're just checking in, you write x as 1 over x, and you apply L'Hopital's rule. So this thing goes to 0. So here's what's happening. ln of y goes to 0. So y has to go to e to the 0, which is 1. And by the way, the fact that you can just exponentiate this limit follows from continuity of the exponential function. In general, this is a dangerous thing to do, but here we're okay, and therefore limit as x goes to 0 plus of x to the x. It's the limit as x goes to 0 plus of y, and that's 1. So surprisingly, it's this power that works because it's the final answer is 1. Let me see. I think that's what it is. Yes, 1. Okay, and last but not least, maybe one of the most famous limits of them all, it's the following one. The limit as x goes to infinity of 1 plus 1 over x to the x, which is of the form 1 to the infinity. So again, there's this tug of war going on. 1 wants to have a number stay at 1. Infinity wants to make it as big or small as possible. And the question is, what's happening here? Well, same technique as before. You destroy this power by using ln. So let y be 1 plus 1 over x to the x. Then ln of y, that's ln of 1 plus 1 over x to the x, which becomes x ln of 1 plus 1 over x. And now let's figure out the limit as x goes to infinity of x ln of 1 plus 1 over x. Well, it's very similar to the x ln of x example. Namely, you write x as 1 over x of ln of 1 plus 1 over x over 1 over x. And let's just quick sanity check. Is this of the form 0 over 0 or infinity over infinity? Oh yes, ln of 1 is 0. 1 over x becomes 0. It seems that all my limits today, indeterminates, were of the form 0 over 0. Complete coincidence, not always true. And therefore we apply L'Hopital's rule. So it's of the form limit x goes to infinity of, I think, 1 over 1 plus 1 over x. And then minus 1 over x squared over minus 1 over x squared. Lo and behold, this cancels out, and you're left with 1 over 1 plus 0, which is 1. But just beware, the final answer is not 1. What we get is ln of y goes to 1. And therefore, y goes to e to the 1, which is e, as x goes to infinity. Which hopefully makes you go e, because this means that the final limit of 1 plus 1 over x to the x is actually just e. Which is pretty interesting because, again, this 1 to the infinity, you think it might be 1, it might be 0, might be infinity. Well, it turns out in this case it's just e. Alright, I hope you like this L Hopital starter pack. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.